Okay, pre-calc students, we're now on big list problem 41. The left side is the more complicated side, so I'm going to change this side. I see that I have the square of a binomial, so it's a square of cotangent theta plus 1. A common mistake is that people will try to square each term, but that doesn't work when you have a plus or a minus in here. So what does work is to square this by multiplying it by itself. So that would be, let's make sure I have the right pen. Cotangent theta plus 1 times cotangent theta plus 1. So I squared it by multiplying it by itself and bring everything else down. Okay, now I'm going to distribute. Cotangent times cotangent is cotangent squared theta. Cotangent times 1. 1 times cotangent. And 1 times 1. Alright, cotangent plus cotangent is 2 cotangent, and I have a minus 2 cotangent here. So those like terms are going to all cancel out. And now I have cotangent squared plus 1 equals cosecant squared theta. So I'm going to look at my identities list because that looks like one of my Pythagoreans. Let's see. Alright, the last one here says cosecant squared is the same as 1 plus cotangent squared theta. So going back, it looks like I can take my 1 plus cotangent squared theta and substitute cosecant squared for both of those together. So cosecant squared theta equals cosecant squared theta. Done. Okay, in 37, I have cosine, I have sine, and I have tangent, and I'm supposed to make all of this into a secant. And I remember that secant is 1 over cosine, so I'm going to probably try to keep my cosine and see if I can do anything else to make the rest of this into cosine. Well, the sine, that's 1 over cosecant, that's not going to be helpful, but the tangent I know is sine over cosine, so I'm going to try to do that substitution. So bring this down. Okay, so that didn't cancel anything out like I had been hoping, but I do have sine times sine is going to give me sine squared in my numerator. If I want to combine these two into one term, I'm going to need to have a common denominator. So I'm going to multiply my first term by cosine over cosine so I can have a common denominator of cosine. So cos theta over cos theta times the cosine theta plus, we already said sine times sine is going to be sine squared over cosine theta. So cosine times cosine is cosine squared. And I have a common denominator, so I can combine those. Cosine squared plus sine squared over, and the common denominator is cosine. Alright, now I know this is one of my Pythagoreans. Sine squared theta plus cos squared theta equals 1. So I can substitute 1 for that. 1 over cosine theta. And now it looks like we're on the right track. So 1 over cosine I know is equal to secant, so your last step is to write secant theta equals secant theta. And check. Alright, let's see what's next. Okay, I added in this one more classwork problem because I thought it would help you with the homework problem, which is number 50. So it looks to me like the right side is my more complicated side, so I'm going to change the right side. And what I'm going to do is I'm going to factor the difference of squares that I have here. So I'm just going to remind you of an example from algebra when you factored difference of squares. Remember, if you had a question like x squared minus 9, the factors would be x minus 3 times x plus 3. So that if you were to multiply these, it would get you back to x squared minus 9. So the same thing with sine squared minus cosine squared, that factors to be sine theta minus cosine theta times sine theta plus cosine theta. And let me erase the algebra now. Alright, and then my denominator is sine theta minus cosine theta. So now because these two are being multiplied, I can now cancel these out in numerator and denominator, and I'm left with sine theta plus cosine theta. And I'll bring that down here as well. And that was done. Okay, so once you finish with your classwork problems, make sure you do all of the homework problems that are listed for day 2. They're on your homework calendar and they're also on Blackboard.